In this video, we're going to begin looking at Chapter 6, and Chapter 6 is on discrete probability distributions. Before we jump right into what these are, we're going to look at a couple of terms. Some of these you might be familiar with, or they might look similar to some of the other things that we've seen in this course, but we want to just go ahead and make sure that we have that down before we move on. All right, so the first thing is random variables, right? What are random variables? We've talked about variables. We've probably also talked about random variables, or at least I've probably mentioned them. All right, this is essentially a random variable. It's just like the variable that we got from kind of the definition we had in chapter 2, I believe, right, where we were going over those that information about data sets. Right, that is what, in essence, what a random variable is. We're going to give a slightly different definition that is more specific to what we're looking at here. Right, and here we're going to say it's a numerical outcome of a random process. Right, in this chapter, right, kind of starting in this chapter and then especially moving forward into the next couple of chapters, we are going to be looking at kind of numerical stuff rather than any kind of categorical stuff. So we're going to be looking at processes that give us a quantitative answer, right, and a quantitative outcome rather than a categorical outcome. All right, so we're just kind of stating that. And then RV, that's just an abbreviation. If you see me write RV, that's random variable. All right, then, let's see, can I fit that? Probably not. Let's just go ahead and erase this. All right, the next thing is probability distributions. All right, we're looking at discrete probability distribution, so it'd probably be good to know what a probability distribution is in general. All right, so a probability distribution is a model that describes a specific kind of random process. All right, so here the random process, this is essentially just our experiment, whatever it is that we are doing. And the model just tells us, well, it's going to, we'll get into that in a little bit later, right? The act of actually describing one of these models. Right, so that's what this chapter and really kind of the next chapter is as well. Right, we are trying to kind of describe these processes. There is a distinction though, right? Because as we're going to talk about this again in a little bit as well. We're going to make a distinction between discrete and continuous, right? So remember that if we have quantitative data, it's either continuous or discrete. And so we're going to, and the differences between those two types of data or types of outcomes is going to require different methods for finding probabilities. All right, but that is what a probability distribution is. When we get to looking at these probability distributions, one thing to note, we've already talked about this a little bit. Right. Just remember that when we see a capital X, that is our variable. All right, that's the variable overall, the kind of the thing that we're interested in. Right. Whenever we see a lowercase x, that is going, and usually it's got that subscript I in most of what we're doing. Right, that's the ith, kind of in this case, the ith outcome of our random variable. All right, so the ith outcome of the random variable. So this might be, you know, our variable might be, I don't know, I don't know why this popped into my head, but what score did you get on a round of golf, right? Or on a specific hole, we'll even say, right? So the kind of score on this hole is the overarching variable, right? Our outcomes would be, you know, 1 to, I guess, infinity if you're just a really terrible golfer. Me, I usually just have to pick up after going double par, but again, that would be kind of the outcome, right? Or a potential outcome. All right, so now let's look a little bit at the difference between our discrete and continuous random variables. So this is essentially should be fairly familiar, all right? When we're looking at a discrete random variable, right? This is a random variable which has a countable number of possible outcomes. Right, and really what it boils down to is that a discrete random variable is just a random variable that is discrete, right? That's really just switching those words up, but remember that for data to be discrete, right, discrete data, it's data that possesses gaps, right? So we can't just take any value, right? We are restricted to a set of values that possess gaps. If our data fits that description, right, then it is a discrete random variable, all right? So that is what that is, right? Again, the difference is just the exact same thing that we learned in, I believe, chapter 2 as well, right? The difference between discrete and continuous, that still holds. All right, now let's talk about how we're going to describe a discrete random variable. Right, so when we're talking about describing a discrete random variable, right, what we're really talking about is how to make a probability distribution for a discrete random variable, right? Probability distributions describe a specific kind of random process. So if we're describing a discrete random variable, right, that is what we're doing. We're just creating one of these discrete probability distributions. All right, so when we go to describe a discrete random variable, first thing, right, we need to state the variable, right? We need to know what it is we're looking at. All right, second, we need to list all possible outcomes. And 3, we need to determine the probabilities of the outcomes. All right, so once again, when we're describing a discrete random variable, first we need to state the variable. Second, we need to list all the possible outcomes. Third, we need to determine the probabilities of those outcomes. All right, so let's take a look at an example. All right, so we're gonna do something fairly simple. All right, so our random process, we're gonna say is roll a d4 for any, it's just a 4-sided die. Anything that D and then any number, that's just how many dice, or how many sides are on a die, right? So roll a d4 and record the number that's kind of facing up. That's not really how d4s work, but whatever number is however you read that number, right? Whatever number gets rolled, we're going to record it. All right, so if this is our variable, right? The number, right? The number that's been rolled, right? So we could even just say x equals number rolled on d4. All right, so we've stated our variable. All right, then we would need to list all of the possible outcomes, right? So usually we're going to put x here, right? X equals number rolled on the d4. We don't want to have to write all of that in there. All right, so instead we're just doing x, right? And then we think, well, what are the possible outcomes? 1, 2, 3, and 4, right? So we've got those 4 outcomes, right? Then we need to find the probabilities, right? So this is the kind of format that we're going to be using from here on out for probabilities, right? So we're going to have probability x equals, and then whatever value that we're looking for. If we were looking for the probability that we roll a 2, right, that would say 2 there, right, so on and so forth, right? But this is the setup that we are going to be working with, all right, from now on, all right? So then we need to determine, so we've listed our variable, right? We've stated our variable. We've listed all of the possible outcomes. Now we need to determine the probabilities, right? So for this one, it's pretty easy, right? One, we could just probably just write that down without even having to think about it that much, all right? But even if that's not the case, we can use that classical approach to probability, right? And for each one of these, how many outcomes are in the event, right? Divided by the total number in the sample space, right? Well, for each one of these, it's going to be 1 over 4, right? So that's going to give us 0.25, all right, for all of these. All right, so that's a pretty simple, just a pretty simple example of this, but really the only thing that's going to be different when we go into some of the more complicated stuff is the only thing that's really going to be different is how you find these probabilities, right? So we're going to look at some different ways, some more, some slightly more difficult ways. They're not that difficult, especially once you kind of get used to them, right? But that is how we're going to find those probabilities. All right, but that is an example of a discrete probability distribution. All right, we also have continuous random variables, of course. Right, so a continuous random variable is a random variable whose measurements, right, actually, yeah, that's fine, whose measurements can assume any one of a countless number of values in an interval. All right, so again, very similar to, really very similar, just slightly changed the wording and how we talk about it, but this is very much the same definition that we had in chapter 2. All right, so continuous random variable is a random variable that can take on any value in some interval, right? It's a slightly more wordy way of writing that, but that is essentially all it's saying. Right? Now, we are not going to be talking about these continuous random variables in this chapter. We're going to save that for the next chapter, in chapter 7. That's when we're going to dive into these. All right, this chapter is focused specifically on discrete random variables. All right, but that is it. The next thing we're going to do is, or in the next video, we are going to dive deeper into those discrete probability distributions. We're going to look at some kind of properties they have, right, so on and so forth. But that is in the next video, and I will see you then.